Hello, everyone. So as I mentioned in classroom, we're going to do a couple final lessons this week and finish it up with a Delta Math assignment by the end of the week. So we're going to continue by looking at, there's three other trig functions out there. So far we've looked at sine, cosine, and tangent, which you have seen since geometry. Here are the new trig functions and how we abbreviate them. We have secant as SEC, cosecant, CSC, and cotangent, COT. Now they're connected to sine, cosine, and tangent. Now if you end up ever having to take a trigonometry class, there's a lot of identities, a lot of trig identities. So we're going to start with these. And first we're going to take a look at something called reciprocal identities. And I'm going to start with, actually I'm going to start with cosecant. So cosecant of an angle we'll call theta is just the reciprocal of sine. So I'm going to write it as 1 over sine theta. But all that means is whatever fraction we get for the sine of our angle, we simply take the reciprocal of it. Then I'm going to go to secant. Secant of an angle is equal to 1 over cosine of that angle. So secant theta is equal to the reciprocal of cosine theta. And then we'll do cotangent. This is probably the only one that makes sense because it has tangent in its name, but cotangent of an angle is equal to the reciprocal of tangent. Now here's an easy way to remember it. Obviously what I just said, cotangent is going to be the reciprocal of tangent. Now you would think, because sine starts with an S, that secant would be the reciprocal of sine, but it isn't. So I always say, whatever one starts with an S, its reciprocal starts with a C. And vice versa. So sine is the reciprocal of cosecant, cosecant is the reciprocal of sine. Another identity we're going to look at to help us out here are quotient identities. We already saw from finding the exact values of tangent, we see that tangent theta is equal to sine theta over cosine theta. And we could write a quotient identity for cotangent. And since cotangent is the reciprocal of tangent, I simply flip this fraction. So this would be cosine theta over sine theta. So that's another way to view cotangent. So we have our reciprocal identities and our quotient identities. So let's take a look at some examples. Now what we were looking at previously on that graded assignment and then back from problem set, it may have been 2 or 4, you were given this statement here, sine theta is equal to 4/5. And then I was just asking you to maybe find tangent theta or cosine theta. But here we're going to find the other 5. I'm actually going to list out all 6. We'll just repeat what we're given here. And the best way to start this, if this is not indicated that it's part of the unit circle, we just need to draw a right triangle. And we need to label theta. Now sine is equal to opposite over hypotenuse. So that would make this leg 4 and the hypotenuse 5. Now, technically, this is a Pythagorean triple, if you guys have ever heard of that or remember that. But if not, you can still use the Pythagorean theorem, but the third remaining side is just going to be 3, because 3 squared plus 4 squared is going to equal 5 squared. So now I'm going to write all of these out. I'm going to start with what was given. Sine theta is equal to 4/5. Cosine theta would be equal to adjacent over hypotenuse, so that's 3/5. And tangent theta is equal to opposite over adjacent, so that's 4/3. So we were doing all of those before. Now we go to the reciprocal. So again, what is the reciprocal of sine? Remember, if that starts with an S, its reciprocal starts with a C. So that would be cosecant of theta is simply the reciprocal of 4/5. So that's 5/4. Where sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite, but it's a lot easier to just flip the fraction. Reciprocal of cosine, if that starts with a C, its reciprocal starts with an S. And it's just the reciprocal of 3/5, so that's 5/3. And then cotangent, which is the reciprocal of tangent, that would just become 3/4. And then that's the extra stuff that we're doing today, that we're learning today. All right, so I want you guys to pause the video, do this problem exactly the same way. Draw that right triangle first, label theta, and then figure out which sides become radical 2 and 3. Pause the video to do that. If you need more time, just pause the video again. All right, so here again we have our right triangle. Here's theta. Cosine is adjacent over hypotenuse. So adjacent, this side here to my angle, would become the radical 2. My hypotenuse is 3. So I'm going to use a Pythagorean theorem here. I'll just call this side b. So we'll get radical 2 squared plus b squared equals 3 squared. So that's 2 plus b squared equals 9. B squared will equal 7. So b is radical 7. So this side here becomes radical 7. All right, so now let's write out all 6. So we have sine theta. We start with sine. So sine theta would be opposite over hypotenuse, so that's radical 7 over 3. Cosine we were given as radical 2 over 3. Tangent theta is opposite over adjacent, so we get radical 7 over radical 2. Well, we need to rationalize this, so I'm going to multiply top and bottom by radical 2. So we get radical 14 over 2 for tangent. Now to write out their reciprocals. So again, reciprocal of sine would be cosecant. Now, yes, that will become 3 over radical 7, and we need to rationalize. So here we will get 3 radical 7 over 7. Then we'll have secant theta becomes 3 over radical 2. Let's rationalize. We get 3 radical 2 over 2. And then cotangent theta. I could start with radical 2 over radical 7, but let's go straight to this. Let's just flip this. We get 2 over radical 14, and let's rationalize. So we get 2 radical 14 over 14, and we can go one step further because 2 and 14 simplify, so we get radical 14 over 7. That becomes a 1/7 there. So some of these do require a little bit more work, especially if we have to rationalize and then simplify after that. All right, our third similar example, if tangent theta is equal to 4, find the other remaining trig ratios. So what we want to do is turn this into a fraction or a ratio and put this over 1, and it's the same process. So if you wish, pause the video, give this a try on your own. Okay, so let's see what you were coming up with. Let's draw a right triangle, label theta. So tangent is opposite over adjacent, so that makes this side 4, this side 1. Let's use the Pythagorean theorem to find the length of the hypotenuse. We'll get 4 squared plus 1 squared equals c squared. That's actually going to give us 17. So c is equal to radical 17. So our hypotenuse here. All right, so let's write out sine theta is equal to opposite over hypotenuse, so that's 4 over radical 17. And hopefully you guys can visualize this, or if not, you could write it out. But if we multiply top and bottom by radical 17, this just becomes 4 radical 17 over 17. Cosine theta becomes 1 over radical 17. And then this will just become radical 17 over 17 if you multiply top and bottom by radical 17. And we already had tangent theta is 4 over 1, or just 4. Let's get the reciprocals here. So we'll have cosecant theta. Now, I'm not going to go to what we rationalized. I'm going to go straight to what we first wrote out because this is going to be a lot easier. This reciprocal just becomes radical 17 over 4. And no need to do anything else because the radical's in the numerator. Same thing here. If we have secant theta, that's just going to become radical 17 over 1, or just radical 17. And cotangent, the reciprocal of 4 over 1, is 1/4. Now, what your assignment is going to be is to use the unit circle to create a chart of all of the 6 trig ratios for the unit circle values. So this will be an example here. Find the 6 trig ratios if theta is equal to negative pi. So if we make our unit circle sketch, and we rotate negative pi radians, that means we're going to go this way over to here. Instead of going in a counterclockwise rotation, we just go in a clockwise rotation. So this gets us over to here, technically at pi, just like I said, in a clockwise rotation. But the ordered pair is what we're concerned with. So this is the ordered pair, negative 1, 0. So if I write out all 6, we know sine theta is equal to the second value of the ordered pair, so that's 0. Cosine theta is equal to the first number, so that's negative 1. Tangent theta is equal to sine divided by cosine, so that's 0 over negative 1, which is 0. And then we take the reciprocals. So the reciprocal of sine again is cosecant. What's the reciprocal of 0? There isn't one. So pretty much to get 0, we would take 0 over some number. The reciprocal would be some number over 0, which is undefined. So cosecant is undefined. Secant theta, so what's the reciprocal of negative 1? If I were to put this over 1, I'd flip it. I'd have 1 over negative 1. It's the same thing. And then cotangent, again, I would have the reciprocal of how I got tangent, so that would be a negative 1 over 0, and then that's undefined. We never want to say equals undefined. We just want to say is undefined, or just draw an arrow here to show it's undefined. All right, so when you guys go to view this worksheet, you want to complete anything that's missing. So you're going to have your first column is going to be degrees. Some degrees are given, other degrees are missing. You have to fill in the missing degree measures. Second column is going to be radian measures. Some radian measures are given, others are missing. You'll have to fill that in. Then what you want to do, and if you need to show work on a separate sheet of paper, that's fine, but you'll have sine theta, so you'll have sine of all of those degree or radian measures to fill in. Then you'll have cosine, tangent. Once you have those three, simply take the reciprocals of them. Again, if you need to do any work, because if you take the reciprocal, I just want to show you here. Let's say we had that radical 3 over 2. The reciprocal is 2 over radical 3. You don't want to leave it like this. You have to rationalize. So this is what you're going to need to do on a separate sheet of paper. So this becomes 2 radical 3 over 3. So anytime you flip or take a reciprocal and then a radical ends up in the denominator, you need to rationalize. So you're going to fill in the cosecant, secant, and cotangent ratios as well. As always, guys, let me know if you have any questions as you're working on this.